this is lesson 6.2, solve inequalities using multiplication and division. You should be on page 363. Solving an inequality using multiplication is similar to solving an equation using multiplication, but it's different in an important way, and you're going to see that here in this key concept box. When you multiply each side of an inequality by a positive number, it produces an equivalent inequality. Okay? An example of that would be down here below. You notice this, if I just replace the inequality with an equal sign, this would be x over 4 equals 5. You would have to multiply each side of the inequality by 4, which is what you see happening here. And divide by 4 times 4 cancel. That's why you'd have x on the left and less than 20 on the right. You've done those kind of problems in Chapter 3, but here's the difference in this next statement. If you multiply each side of an inequality by a negative number, you have to reverse the direction of the inequality symbol to produce an equivalent inequality. I'm going to show you an example of that in a minute. So maybe I should just take my pen and put a little red mark here. This is the one that we really have to remember. If you are multiplying by a negative number, you have to reverse the inequality in order to create an equivalent inequality. Okay? So that's important to remember. When you multiply with a negative number and you have an inequality, you must flip that inequality symbol around. Here was an example of multiplying by a positive amount. We just looked at that. If, x divided by 4 is less than 5. So if you think onion, x is the center of the onion, and the next layer is the divide by 4. I got to multiply by 4 on each side, which you can see here. These cancel, x less than 20. That's pretty simple. You're multiplying by a positive in that case. Okay, now let's go down to this bottom example. Here's an example where you're multiplying each side by a negative. So let's look at this carefully. So if I draw up my onion, I have x on top, and then I have divide by negative 6. Well, I have to get rid of divide by negative 6. Do you notice what they do? They multiply each side by negative 6. Now, when you multiply, you notice what they're saying here. We have to reverse the inequality symbol. So look at the original inequality symbol. It was a less than. Look at it now. When they multiply each side by the negative, they reverse the symbol to a greater than symbol to keep this a true statement. And now, divide by negative 6 times negative 6 cancel, and you're left with x greater than negative 42. Okay? And let's just see if that works. Let's pick a number bigger than negative 42 and plug it back into the original problem, so we can always check these. Let's plug in negative 36. Negative 36 is definitely bigger than negative 42. It's farther right on a number line. If we put negative 36 in here, negative 36 divided by negative 6 is positive 6. Is positive 6 less than 7? And yes, it is. That's a true statement. So there's the correct solution. Now, I could graph that now because we need to graph. Remember, this is all they say graph it. This is all the correct solutions to the problem. So let's get out our graph paper. And remember, I have to graph all the values greater than negative 42. So negative 42 is about here. You'll notice I changed my scales to 10. So 10, 20, 30, and so on. And I'm plotting everything greater than that. So there would be a picture of that solution. Now, when you divide, the rules for solving an inequality using division are, again, similar to the rules solving an inequality using multiplication. You'll see those two rules here. If you divide each side of an inequality by a positive number, you produce an equivalent inequality. So that's very basic. However, if you divide each side of your inequality by a negative number, maybe I should underline these, you have to reverse the direction of the inequality to produce an equivalent inequality. So it's the same rules. If you're dividing by a negative, you got to flip your inequality symbol around. So let's take a look at that here. You see how they have negative 3x is greater than 24. Let me draw my onion for that problem. X is the center of the onion, and the times negative 3 is the outside layer. So how do I get rid of times negative 3? Well, I hope you're saying you got to divide. So you notice here, let me highlight it in light blue, they are dividing each side of the problem by negative 3. Now, that gets me to this rule right here. If I'm dividing by a negative, I have to flip the inequality around. So you notice how the symbol started as a greater than. You see how they reversed it. I'm highlighting it in green. They reversed the inequality symbol. And so on the left side of the problem, the negative 3 divided by negative 3 cancel, and you're left with x. I now have a less than symbol, and 24 divided by negative 3 is negative 8. So there's my solution. X would be any values less than negative 8. Okay? Now, they don't ask me to graph this one, but if I did have to graph it, I would go to negative 8 on my number line, put an open circle at negative 8, and shade everything to the left. Let's just do a quick sample problem here. Solve the inequality, graph your solution. Let's try that. So for this problem, you notice here's the center of the onion. We're dividing by negative 4, so I have to times each side by negative 4. Now remember, when I do that, I have to reverse my inequality. So let me just put times negative 4, times negative 4, and I'm going to reverse my inequality. Divide by negative 4 times negative 4 cancels. I have x on the left, and 12 times negative 4 is negative 48. There's my solution. Now they want me to graph it, so let's go graph it. And you can see I changed my scale again to go by tens. Negative 48 would be about here, open circle, and I want the values less than that, which is why I'm shading this way. Now again, the graph is actually the shortcut. I'm showing all the correct answers. It would be impossible for me to write all those out. They will also have you do a few word problems where they're going to ask you to write your own inequality and then solve it. So if you look at this, like a student pilot plans to spend 80 hours on flight training to earn a license. They have saved $6,000 for training. So they want us to write an inequality to find the possible hourly rates that the student can afford to pay. So let's think about it. They want to train for 80 hours. There's going to be we got to multiply by the price per hour, which we don't know, okay? So think about it. If you're going to go train, if you want to train for 80 hours, every hour you got to pay a price per hour for the training, and you only have $6,000, so let me write this over here. 80 times, we'll call this unknown, I'll call it P for price, has to be less than or equal to $6,000. I only have $6,000 to spend. So 80 hours of training times the price per hour, that would be this statement would give me the total cost of the training has to be less than or equal to $6,000. So there's my inequality. So obviously the answer would be B. They used R instead of P. Now let's solve it. If I want to solve that, I have to divide each side by 80, and I'll write it down here. P would be less than or equal to, if I'm doing this in my head right, 75. Let me double check it on my calculator. And yes, it's 75. So in other words, this is telling me that I could afford this training if the total cost per hour is $75 an hour or less. Okay, so as long as they're not charging more than $75 an hour, I could be trained for 80 hours and only spend up to $6,000. I'm going to stop the video there. If you have questions, make sure you ask in class.